Hi students, today I'm going to discussing application number 10. Once see the application number 10, what is given? A body of mass is given. The body of mass is given small m. Is sliding down, means coming down on a rough inclined plane. This inclined plane making an angle theta with a horizontal inclination nothing but theta is given. And capital L is the length of the inclined plane. And this is the rough inclined plane means there is a one coefficient of constant is there, that is the mu k, we called as coefficient of kinetic friction. Kinetic is nothing but in this case motion. So the main aim of this application is here same work done by the resultant force. In this case work done by the resultant force. Now we can see the difference between previous application and this application here. The previous application we are applying the constant horizontal force there, but in this case we are not applying any force, just we are sliding on a rough inclined plane. Okay, now once we can see the diagram according to these applications. First I am taking one inclined plane I am considering. Right, this is the inclined plane. On this inclined plane I am taking, this is the body. So this body of mass is given here small m, and this inclined plane surface, this is a rough surface. So rough means what happened? Friction it is there. Rough means friction it is there. Now once what happened? This in this case is given here sliding down. The word we can see the sliding down means the body is coming to down like this. The body is moving to downward in this case. I'm drawing again, this mass will be very clearly you can see like this. Okay, this is moving downward in this case. Now we can see how many number of forces are acting on this one. There is no any external force applying on this block. So here weight is acting. Here this is the theta, inclination is theta with horizontal, and in this body the weight is acting downward. W is equal to mass into g. Again normal reaction is acting. Normal reaction in this case always what, perpendicular to the inclined plane. This is the inclined plane, this is exactly perpendicular, this is the n in this case. So here weight is a force in this case. Again this weight is resolving into two components, what I discussed in the application number 8 or application number 9 also. Again two components are there, these two components is in this case between these two weight. This is the one component, second component is exactly parallel to the inclined plane. Now this is the inclined angle is theta means this is angle also will be theta. That's why this is we called as in this case mg cos theta, and this is we are considering in this case mg sin theta. Okay, right. Now this block is moving to downward in this case. In the application number 9, the block is moving to upward. That's why I took the their f cos theta is the first. In this case, the block is moving downward. Then I will take in this case mg sin theta is the first in this case. Which side the block is moving, that we have to take the positive value. On the other side, we can take the negative value in this case. But here only two forces are there. One is normal reaction, second one is the weight. That's it. So here asking work done. Work done by the resultant force we need to find out in this case. Now this is the rough surface means, this is the rough surface mean, here what happened, this one you can observe it, this is the rough surface. So compulsory friction is there. So the body in this case is moving to down on the inclined plane means, so always the friction is opposite to the relative motion. Means the body is moving to downward means the friction will be in this case backward like this. Friction I am taking in this case f, small f, and that too in this case the block is in under the motion. Motion means we have to take in this case kinetic friction in this case. Okay, right. Again, we can observe it in this case. X-axis is nothing but like inclined plane, and y-axis is nothing but in this case normal reaction and mg cos theta. Normal reaction is the positive y-axis and mg cos is the negative y-axis. And frictional force is kinetic frictional force is the positive x-axis, and mg sin theta is the negative x-axis. But we have to take which direction the body is moving downward. That's why we can take mg sin theta is the first. So I'm taking in this case work done. Formula W is equal to formula again F net resultant force into displacement. Here displacement in this case, F net I will take, and S is the displacement of the inclined plane. It is given here L. It is given here L. Now F net we have to see in this case. F net is equal to how many forces are acting in this case on the x-axis in this case. First I will take F1 plus F2. Here F1 is nothing but I will take first one is the mg sin theta. I told you mg sin theta is because the body is moving to downward. That's why mg sin theta plus friction is acting to backward, opposite to the mg sin theta. Here we can see both are in opposite direction. So minus small f into suffix k. So finally that is equal to m into g sin theta minus f k. Okay, this value I will substitute in the equation. Then f mg sin theta minus f k into L in this case, into L. So Fk means what? Friction, kinetic friction in this case. So according to the friction concept, if you see, the friction is directly proportional to frictional force, directly proportional to the normal reaction. But in this case kinetic means I will take k, and normal reaction I am taking. Then Fk, if you remove this proportionality, we will get one constant. That constant we are considering in this case mu, and this is the k. Why I am taking the k means in this case the body is under the motion, then the kinetic coefficient of kinetic friction. If you remove the proportionality, then mu k into normal reaction. You can see the diagram. This is the normal reaction is equal to the mg cos theta in this case. N is nothing but in this case what? Mg cos theta from the diagram y-axis. So mg cos theta. So this Fk value I will substitute it in this work formula. So finally that is equal to mg sin theta minus Fk we found here mu k mg cos theta into L. So that is equal to mg is the common sin theta minus mu k cos theta into L. So finally work done is equal to mg capital L sin theta minus mu k cos theta. Okay, so this is the work done by the resultant force on your body. Here the body is on the rough inclined plane. Rough inclined plane means friction is happening. Friction is opposite the relative motion. That's why this is the back side. Okay, this is the work done. This is the application number 10 based on the work done. Thank you so much.